Hello everyone and welcome to the free vehicle detection and counting course. So vehicle detection and counting is a fundamental task in computer vision and plays a crucial role in various applications such as traffic analysis, surveillance and intelligent transportation system. In this course, you will learn about the fundamental techniques and algorithms used for detecting and counting vehicles from a video footage. We'll cover topics such as object detection and tracking. By the end of this course, you have a solid understanding of how to implement these techniques and to be able to apply them to real-world scenarios. So if you are glad about this, let's go through this course together. And trust me, everything is free. At the end, you get a video file, the code, and all other related resources to play with. Alright friends, so welcome to the Ultimate Vehicle Detection and Counting course. So before we get started, I'll first like us to go through the file systems. The files we'll be using in this particular tutorial. So you can see we have cars.mp4, which is the video file we'll be detecting these cars in and also count them as well. We also have classes.txt, so this contains all the various objects you can detect in the Cuckoo dataset. Okay, so we have sort.py, and this is the library that will help us to do counting after detecting these cars. And then this is the YOLO file, which I will show you how to get it. So you just run a script and it will be downloaded if that's your first time you are running YOLO version 8. Okay, so with this out of the way, in order not to waste your time or stress you, I'll just generate the libraries I'll be using in this tutorial. So we do that by writing pip phrase, then greater sign, then let's put requirement.txt. So this will contain all the libraries we'll be using in this particular tutorial. So you can see it's here, and we have almost many libraries. So you can just do pip install requirement.txt in order to get these exact libraries we'll be using in the tutorial. So I'll put everything, including the code and the video files, on my GitHub repo. So the link to all those resources will be in the video description. Okay, so we'll now go ahead and create a new file. We'll go to File, go to New, or we just click on the virtual environment, then we go to New, then select New Python file. So let's name this Vehicle Detection, alright? Vehicle Detection. And also let's add the counting to it, so that counting, is that correct? Okay. So that's out of the way. We'll now go ahead and import the libraries we'll be using in this particular tutorial. So for sure we'll be using OPCV. So we'll go ahead and import OPCV, and this is very small, so I'll increase the font for you. And what we can do is to hide the other part so that you can see everything clear. So I think it's big enough now. We can increase it once again. So import CV2. Import sort, or we can do it this way. From sort, we are importing everything. So from sort, we'll go ahead and import all. And to import all, just bring asterisk in front of the import. We'll also import math, the math module for some calculation. See, so just import maths. And the next library is NumPy. So we import NumPy too. Okay, we are forgetting one library, which is the YOLO we'll be using. So we'll say from Ultralytics, we are importing YOLO. So YOLO is all caps here. Don't forget to put that. Right, so these are the libraries we'll be using. Before I forget CVZone, let's also import CVZone. So simply import CVZone. Okay, so we are done with the libraries now. The next step here is to read our video file so that we know the video we'll be working with. So let's go ahead and do that. For that, we create a captcha on here to say cap, and this is equal to cv2.video captcha. So video captcha. And in here, we have to specify the path to our video. So I'll bring this back. I can see the name of our video is cars.mp4. So I'll quickly type it in here. And it's cars.mp4. No, it's cars2. Instead of cars, we have cars2. So I'll quickly bring the 2 here. Okay. So now we have to take this frame by frame. And to do something repeatedly, we either use for loops or while loop. So we use while loop here. So we say while true, which is the same as while one. So let's make this short. We want to get our video feed. So we say read, and our video frame, which we want, is equal to our captcha.read. So we are reading whatever is in our video captcha, and that is that. So after this, we'll go ahead and show this video file. So to show it, we use the cv2.ishow function. And in here, we provide our thread that we want to show on. And whatever I want to show here now is the video thread. Right. And after showing, we have to wait each frame, wait some seconds. So we have another function for that, cv2.wait key plus key. I will give it a wait key of 1 so that we can loop it over and over and over. So I'll go ahead and run this now, and you can see boom, and you can see here's our video file. So you can see the cars moving. So these are the cars will be detecting. But before that, let's do one thing quick. You can see when I run it, the video is not that long, so for some time it will just stop. So let's make this repeat for some number of times, like let's keep it repeating. And for that, we can just come here, we'll say if rate, or let's say, yeah, let's do it if rate. If read, whatever I will do is to what? Load our captcha object again. So let's copy this. Right here, we load our video captcha. Then after that, we'll continue the video once again. So with that, we'll get a repeated frame. So let's test this out. Okay, so this series not coming. I don't know. Let's check. Okay, if red, or if not red, so if not red, all right. Let's try this out. You can see we have our video file here. So it's working this time. Now it's repeating over and over and over. It's just repeating the same video frame over and over and over. It will never end. So that's a simple hack you can use to repeat a short video frame over and over and over. So we say if not read, what this returns to us is the presence of video or not. So we are saying if we have no video, then we want to read our video file in, and we'll continue so that it will repeat over and over. Okay, so now we are done with that part. We have to now focus on how we can detect the cars in the video file. So to detect these cars, we are going to use the YOLO model. So we have to first of all load in this model. So we'll go ahead and load the model at the top here. So let's see, our model is equal to YOLO, and then here we provide the name of the model. So we have the large model, the nano model, and the medium model. We have so many of them, but here we'll be using nano because we are running on a CPU. If you have GPU, you can try the large, which gives you much higher accuracy but slow speed. So it's between speed and accuracy. You either go with speed or accuracy, and it depends the type of problem you really want to solve. So here we are going with the nano version. So we'll say YOLOv8 and .pt, which is the nano version. So you must have an active internet connection to run this script now, because for the first time it will go and download this particular module for you. So you have to get an active internet connection for it to work. But if once you have run it and it has downloaded, the next time you want to use it, you don't need active internet connection because you have the module. So when we check here, you can see I've done this before, so I have the module here. So I'm just loading this module here inside the Python script. Okay, so now we've loaded this module here. All we have to do is come in our code and just try to detect some objects. So we just come inside our code and we can say our results now is equal to this module we have loaded. And what we'll do is I will give our feed to this module, to our frame. Whatever we are getting from the video, we are giving it to this module so that it will detect whatever is in our feed. So in this case, our emphasis, we are laying emphasis on the cars. And another argument you can put here is string. Now we'll have our results stored in this result variable. And what I mean by result is our bounding box, our class name, and the confidence. So assume it has detected a car. What is the percentage or what's the confidence value that shows, okay, it's a car? So all those stuff will be stored in this variable result. So we have to look through this result some couple of times to get our information. So to look through this, we can say for loop for our info in results. So whatever information is in which is in this result, and put it into our boxes, or let's put it in a variable called boxes, which is equal to our info dot boxes. And the next thing we have to do now is also look through these boxes we have here. Then we'll get our bounding box, our detection confidence, and our class name. So we just say for box in our boxes. For box in our boxes, we want to get our bounding box. So let's first go with the bounding box. So the bounding box will get x1, y1, x2, and y2. So this is equal to our box dot xy, that's dot xy xy at index 0. So we have other stuffs in there, so we are picking whatever is in the index 0 so that we can get our bounding box coordinate. So with this coordinate now we can draw rectangles on the cars we've detected, right? But we'll continue to get other stuff before we do draw the rectangle. So we can get our confidence, to which we will store in a variable called conf. So this is equal to our box dot conf, right? So that will give us our detection confidence, and we are also taking it at the first index. We'll do same for our class name. So I'll call this class, or class index. Let me call this class index is equal to our box dot cls, which means the class, particular class detected. We are also picking this at the first index. Okay, so now before we can draw the rectangle, we have to do some calculations, or we have to do some conversions. So these points we are getting here will be floating point numbers. So we have to first convert them to integers. The same thing applies to the confidence and the class index. So let's come one step down and convert them to integers. So for the x1, y1, what we can do is that we can define them again. So x1, y1, x2, and y2 is equal to integer of whatever x1 is. We do the same for the rest of them. Okay, so now we are done with the conversion for the bounding box, and we'll do the same for the confidence. So for the confidence, we use the math module we've imported. So we'll still store it in conf, and we said it's equal to our math.ceil. So you can either use math.ceil or math.floor to make it an integer. So we are sealing our confidence value here. And what I'll do is multiply it by 100 so that we get it in actual percentage. So if we get like 10, that means it's 10%. If we get like 20, it's 20%. So we are not using floating points here. If you want to use floating points, you can just divide all of these by 100 again, and that'll be fine. For now, we'll just use the actual percentage. Let's do the same thing for our class name. So you can see our class name. That's class index. Our class index is equal to integer of whatever our class index is. Okay, so this will be fine. So for now, I think we can draw a rectangle for our detected object using the points we've converted. So we'll use cv2.rectangle. And in here, we are putting the rectangle on our frame. So that our first point will be x1 and y1. Our second point will be x2, y2. Then now we have to provide the color of the rectangle. So we'll give this 0, 2, 5, 5, and 0. So this is green. So we are giving it a green color, and the thickness of this rectangle, we want it to be 2. So let's run this and check what we'll get. Boom, you can see everything is working. So you can see the first car coming is well detected. Wow, so this is working fantastic. It's working. Everything works. You can see, so the car is being detected. You can see another car passing at the other side, which is also detected. So this is working fine now. So let's go ahead and put the class names and all those stuff on it, and also the detection confidence. So I'll close this out. Okay. So to do that, to get the actual class name, first let me print this out for you guys to see. Let's print the class index. So let me run this. And I see we are getting 2, 2, 2 here. So let me close this up. You can see the class index we are getting here is 2, 2, 2. And this is because we are detecting a car. So if we should open the classes.txt, you can see car here is at 2. It's 3 here, but we know we start from 0. So the first one here is person, which is 0. Bicycle is 1, and car here is 2. Right? So YOLO only gives you the index. So we have to use our classes.txt to match our index to the actual object detected. So for that, you have to first read in these classes into our Python file. And this is very easy to do. So come at the top here. My zoom is too big. We'll come at the top here and we'll come and load this in. So let's construct an empty list. So we say class names is equal to an empty list. And we will now read in these classes in the list. So we say with open. Then what's the name of the file? The name of our file is classes.txt. And we are opening this in a read mode. So put R here. And we are reading it as F. Now our class names is equal to f.read. So we'll read everything into these classes, and we want to split each line, so when we use split lines, right, everything will be stored in the classes list. And to check this, we can just come down here and print the first items in the class list. So class names at the first index 0, and if this works, we should get person in this case. So let's run this. We just run it, and okay, so and go to the top, you can see where is person. So you can see we got person here, and raise this up. You can see we got person here exactly. That means we are accurately reading all the classes into our file. We can also get rid of this line here. So now let's merge everything its classes. So if you are detecting a car, let's make this display on the at the top of the bounding box that okay, we are detecting a car. And to do that, we can just put it, we use CV zone to do that. So we can say CV zone dot put text rate. So CV zone will just give us a fancy nice rectangle that will look very attractive and appealing. You see that in a second. So we just provide your frame on which you want to put the rectangle, and now the text on which the text that you want to put on this rectangle. So what is the text? Let's use a string here. The first thing we want to put is the name of the object detected. So the name will be our class names, whatever we have read in our class names, and the index of our class index. I said that in the index of our class index, right? And we also want to put the detection confidence, the percentage at which our model believes this is a car or not. So we also put that, and that is stored in our variable. And in order to make it look good, we can put a percentage sign to it. Okay, the next thing is the position at where we want to put it. So we want to put it right at the top of the bounding box. So that will be in ellipse. So we want to put it at x1 and y1. Now in order for it to be at the top of the bounding box, we have to add 8 here to x1, and then y1, let's subtract 12. If the position is not good, we can change it. Also, we have the thickness of the text, so the thickness will set it to 2, and we can also use the scale value. Let's put the scale 1.5, and let's run this now to check. Okay, so our script is running, so you can see it looks nice now. Car is being detected with an confidence of 80 something. This is 70 something. So guys, this sounds up with our detection. We are getting good detection now. So you can see the model is just accurate. Detecting car, track, right. Okay. So one thing we can also do now is that we have to focus on whatever we want to detect, because we have other objects in a real world scenario. We have other objects passing by, so we have to be specific about whatever we want to detect. So for that, we can just close this up and put up some if statement at the top that okay, if this is this, then we are detecting this. So we can put it here before our conversion. Right, now we can bring it down here. So tag in, and that means we are going to check this based on the confidence. So we can send the confidence up. We bring it somewhere here. Then we count down, and we can say if our class name. So for that, we have to also bring this at the top. This is the class index, so that when we detect a particular class, we get the bounding box info and put it on it, and this class will focus on will be cars, bars, and tracks, because on the road, those are the stuff we want to dictate. And if we want to do that, then we should class name in the index of class can also come here. We can put it in object dictate. Object dictate, let's just write like this, is equal to our class names in the index of class index. Okay. So what we can do is to come here and change all these stuff here to object dictate. Okay, so we can now continue by writing our statement here that okay, if the object detected is car, track, and so on, we'll go ahead and do whatever is necessary. So I say if our object detect is equal to car, then you can see all these files in the txt file here. So we are focusing on tracks, bars, and also cars. So we focus on these three. So say if our object detected is car, or our object detected is a bus, and the final one, or our object detected is a track, then we go ahead and do something, right? But we have to also do that based on the confidence. So you can add and the confidence is also greater than, let's put this 60%. Then we'll go ahead and do something. So in order for you to see, we can break this down here. Oh, we are getting an error, so let me put it on the same line. I can close this one up here. So what we are going to do is that if our object detected is a car, bus, or a truck, and the confidence at which we are detecting it is above 60, then we are going go ahead and extract the bounding box and draw whatever we want to do, and draw the extract bounding box and draw it on the particular object detected. So we can tab this one in, we can tab all of this in, and can get rid of this space. Okay, so let's test this by running it before we continue. Okay, so now we are only detecting cars, trucks, or bus based on their confidence. Okay, so for now we are done with the object detection part. So we'll move to the tracking part, how we can assign ID to each object detected, and then we'll focus on maybe how to count them based on the direction they are going. So I told you earlier on that we'll be using the sort library, which we've imported here for counting the cars. So we'll first use it to associate ID for each car, then we'll use it to count the cars. And to do that, we have to first create a detector object. So we'll call this tracker, and this is equal to the sort. And inside here, we have some parameters we have to change. Let's say max age, we can send it to 20, and that's enough. We have other parameters, but you can leave them as default. All you have to do is to increase the max age. Okay, so this is how we initialize the tracker, and this tracker accepts some information, then it will give us an extra information. So what are the informations we need to provide for this tracker? And this is what we'll be doing next. So what this tracker wants from you is the bounding box coordinate. You have to give it all your bounding box coordinate and your confidence. So you can see we have all those things here. We have our confidence, we have our bounding box coordinates, the x1, x2, y1, and y2. So we have to push this to our tracker. Then our tracker will give us our new bounding box coordinate and also provide us with an ID for each detected object. So for that, we can come down here and say, okay, let's do it right here. So let's tab in, and can say our detection our detections is equal to np dot empty. So in here we give a range from 0 to 5, right? So now that we have our detection variable, we also go ahead and put the detected coordinates in this detection. So for now, we have to come down after getting the particular object detected. So we can come down here and say, okay, so let's first do it for a new detection, because after the if statement, we are going to get new detection. So we can say our new detection. What is one has called detection? Our new detections is equal to np.array. And in this array, we are going to give it our information. So give it x1, y1, then x2, and lastly y2. I told you the last thing it accepts is your confidence, so you have to provide in the detection confidence as well. So these are the parameters you have to give to the sort tracker in order to give you the ID, which will be associated to each and every vehicle. So what we'll do next here is to send this new detection to our detections array here. So for that we will say, what is it? For that we will say our detections is equal to mp.vstack. We'll stack this vertically. Then we'll give this our detections and also give it our new detections. So we are first giving it our detection range we've defined here, and then we'll add the detections here, which are the coordinates and the confidence we are getting here. Okay, so this is fine. And now since we'll be getting IT, we don't need to draw all of these tabs again, so we can comment it, but we'll need this code when we are putting the IDs on them. So all we'll do now is come down here and initiate our tracker. So to initiate our tracker, we'll just say tracker.update, then we put in our detection. So we say tracker.update, then whatever we want to give it here is our detections, that's all. And this will return you with the results. So we'll save this in tracker results, or let's say track results, so keep it simple. So track result is equal to tracker.update detections, and this result will contain our ID and our coordinates. So let's loop over the tracker result to get our ID and our coordinates. So for that, let's just say for results in track results, we'll get our x1, y1, x2, and y2. Then the last thing to give us is the ID is equal to our results. So this is how simple you can get all of your bounding box again. And since we have this bounding box, we'll go ahead and do our conversions that we did here. We have to convert it to integer once again, so that we can use it to draw a new rectangles around the object detected. And now what we'll do is I will add the ID too, so we can come here and add. Okay, so this is cool. And to prove this is working, we can draw our rectangle and also put the ID on the rectangle instead of so. We've done this before. We can just come and copy this whole code here, and instead of class names and styles, we just put ID on it. So let's paste this here and uncomment 8. Then here, instead of putting the object and stuff, we'll clean all of these. So we'll bring this up and put our ID. So this is cool. So let's run this and check whether we are having the ID at top of every detected bounding box, because we are drawing the bounding box as well. So let's try this out. So you can see we are getting it 1, 2. So this is assigned 4, 5 at the back. So we are getting some IDs on them, right? So that's fantastic. That's working. So now we are getting the ID. So how do we count now? That's the next question. So work on the counting part, which is also very simple to do. Okay, so in order to count, we have to get a line so that when the vehicle crosses this line, we know, okay, we can count it. So let's say we have a line somewhere at where the mouse cursor is. When it crosses this line, then we say, okay, we can count. But how do we know the vehicle has also crossed that line? That means you have to get a point on the vehicle so that when that point intersects with the line, we'll know, okay, the vehicle has crossed the line. So for that, we just divide this bounding box into 2, and then we'll get the center point. Then when we get the center point, when this center point crosses the line on the road, we know, okay, the vehicle has crossed the line. Then we count it to the number of vehicles that have crossed that particular road. So let's go ahead and do that. So to do that, first we need the width and the height. So we'll come somewhere at the top here. Right after here, we can get our width and the height. So you see our width and our height. And to get the width, we said that's x2 minus x1. Subtract x1 from x2, and we do the same for the height, y2 minus y1, so that we can get the width and the height. So now that we've gotten the width and the height, from this width and height, we can get the center point of the bounding box surrounding the particular object detected. So let's call this one CX and CY. CSCY, that's type 2. And this is equal to our x1. So for CS is x1. Then we add this to our width and divide it by 2. So bring double division sign because we want it as an integer. I will do the same thing for the height, y1 plus the height. Then we divide it by 2 also. So with this information now, we can get the middle of the bounding box surrounding the cars detected. And with this information, we can draw a circle that when it crosses a line, we know the car has passed a particular point, so we should count it. So to draw this circle, we just come down here and draw it. So I'll bring this down. You can say CV2.circle, and to put this circle on our frame, and the points for this circle is CX and CY. Okay, then we'll specify the radius of this circle. So let's make it 5. Then let's make the corner red, or let's make it yellow. Let's make the corner yellow. So for yellow, 0, 255, 255. And then the last is the thickness of the circle. So we want it to be a round circle filled with the particular corner. So you just put -1, or you type CV2.field, all in caps. The field all in caps. So with this, we can get our circle. Let's run this and check out. So you can see we have a yellow circle on the car. Particular vehicle detected. You can see the yellow circle on it. You can see we also have yellow, so it's hard to see. So let's make it red so that we can visualize this. Okay, and we can also increase the radius of it so that it will be big enough for us to see. Okay, so now you can see the red color detected in the middle of the bounding box of the vehicle detected. Okay, so now the next thing is to draw this line so that when this circle intersects with this line, we know the vehicle is crossing that line, so we have to count. right? So that's what we'll do, because in the normal road, you can see another car passing somewhere else, and it's also having a particular ID, but we don't want to count that car. We only want to count cars that passes through a particular point of the road. Okay, so let's close this out and draw the line. So we just come here and draw our line, but before that, let's put the coordinates for the line. So I'll come down here and I'll say line, and then I will give the coordinates of this line in the list. So line is equal to list of the first point will start from 320, then will go to x, y1, which is 350. I will put this one to at 620, and the last one will also be 350, because we want the y-axis to remain the same. So now we can come down here and put the line, put it right after our tracker objects. So when you say CV2 dot line, and inside this line, you want to put it on our frame. Then the first position you want to put it is our line at index 0, right? I want to put it at the index 0, and the same thing you want to do for index 1. So line at index 1, that's 1. Okay, so the next we want to put line at index 3, and the last one line at index 3. So we are just getting the index of the numbers we've put in here. So we started from 0. This is normal list 0, 1, 2, and 3. So that's what we are getting here. Just putting those coordinates into our line. Okay, let's see. Okay, we didn't close this up, so we'll get rid of one here, then we'll close this one up. So that's fine. And after putting the line, you have to select the color of the line. So let's make this color now yellow. So we'll make it yellow 255, 255. And let's make it big enough. So let's make the thickness maybe 6 in this case. So let's run this up and see our line. Okay, since we are having some errors, so CV2 dot line at index 0. Oh, okay, so we had an error here. Line at index 0. This is a list, so it should be a list 4. Let me see, no similar errors. So let's run this. Okay, you can see we have our yellow line here crossing this road. So this is fantastic. Now we can count when this circle reaches where the line is, and bypass will count. So that's what we are going to use to count. Based on the circle intersecting this line, then we can say, okay, the car has passed that line, so we should count it and add it to the number of cars we've gotten. So to do that, we'll come down here and check whether the car is crossing the line. So let's do that here. So we'll say if our line at index 0, right? If the line at index 0 is less than our CX, so CS and CY are the coordinates of our circle, and also less than our line at index 2. So for the x-axis, we have index, no, that will be index 1. Or yeah, it is index 2. So x-axis x1 and x1 and x2. So x2, if this one is 0, this will be 1 and this will be 2. So the x2 will be index 2. So if our x-axis of our circle is in between the line at index 0 and index 2, you have to also check for the y-axis too. So we say end our line at index 1. So for the y-axis, we only check for 1 because we jump from the first line. So for the y-axis, we check for the first line. So at line 1, our line 1 is also less than our cy, which is also less than the same line 1, line at index 1. So if this is the case, then we'll go ahead and count. So to count, we have to initiate the counter here. So we'll count here and say, okay, our counter here is equal to 0. Then what we'll do here is to come down here and increment our counter whenever this happens. So to increase our counter, we just do counter plus equals to 1. So that means anytime this happens, anytime the circle intersects with the line, we want to increase our counter by 1, right? So and anytime we do that, we want to change the line color to see whether whatever we are doing is correct. So anytime they intersect, we want to see whether truly they have intersected. So for that, we can draw a new line color. So let's make it red because it's doing something like danger. So change, and also let's increase the thickness to 10. So when the car bypasses where the line is, we change the line color and we increment our count. So let's just run it and see whether the line color is changing at the moment before we increment our counter. The car is coming, so nothing changed. So what's wrong then if nothing is changing? The problem is that wherever the line is just a straight line, so we have to give maybe some box there so that when the car enters into that region, we know it has bypassed, because the line will be very thin and sometimes it will not intersect with our circle on the vehicle. So for that, we can say, okay, we'll add some value to the y-axis so that when it enters into that ring, so we'll subtract 20 from the first one and we'll also add 20 to the second one, so plus 20. So when we do that, then we can say, okay, now it has entered. We have to change everything. Okay, so let's test this out and see whether it works this time around. So it's scanning. Let's see whether it works. And then you can see it has 10 red because we have given it some zoom. It has 10 red. So this is working. So the thing is, we have to give it some range of values. It has to be a box or a region so that when it enters into that region, it will be detected. So this is working nicely. So let's go ahead and put our count now on the screen. So we will close this up. And now we have to focus on how to put our count value on the screen. So for that, we'll also use CV zone again to put our count. So I say CV zone, we'll put text red. And in here, we want to put the text rectangle and our free. Then we want to put our counter. So we'll use a string as usual, and we'll put our counter in here. Then let's put it at the position. Let's put it at some position that we can change later. So let's give this 600, position 600 by 40. So 600 on the x-axis and 40 on the y-axis right at the top. And we can bring in this, the scale and the thickness value. We can borrow it right from here and also put it there. So I'll put this here. So I think let's run this out Okay, so it says 0 at the moment. Our counter is 0 at the moment. So let's see. 1, 2, 3, and 4. So you can see that it's not counting well. You can see probably, and I know why, because these bounding boxes are being detected on and off. So when it's passing through that region, it will be counting in that region till it leaves the region. So we have to come up with an algorithm or a code that can be able to detect that, okay, this particular bounding box, this particular ID has already been counted, so we shouldn't count it again. And for that, we'll use a simple trick to overcome this. Okay, so what we'll do is that we'll count here. So here we can write total cars. Total, let's just put total is equal to then whatever the counter is. So what we can do is to change this counter here as a list. So we'll turn it to a list, and then we'll check in this list whether whatever the ID is being put in that list already. So we'll say counter.count. We are going to count whatever. We are going to count the ID. So we will count a particular ID given. So if the ID is 1, we'll see how many times 1 has appeared. So if the car is in that zone that we've given it and it's counting 1, 1, 1, we're checking how many times 1 is what there. So we'll equate it to 0. So this is a condition. So let's put it in a condition. So we said if our counter is equal to, of that particular ID is equal to 0, then we'll go ahead and append this. So we'll say our counter dot append, then we'll append that particular ID. So this is just a list that will be appending the values in that particular list. So we'll be appending, if ID is 1, we'll append 1, if it's 2, we append 2, and at the end of the day, we'll just check the length of our counter list to know the total number of cars that has passed. So instead of putting counter here, we'll just check the length of our counter. So the length function, the length gives you the total number of elements in your list. So, and that will be the total number of cars. So let's run this out and check. Okay, so total is equal to 0. Let's see how it gives this time. Wow, so it's working now. The first car, we just got 1, 2. Wow, this is working great. But for visualization purpose, we can bring this one back to, let's say, let's make this 500, and also increase the thickness or the scale. Let's make the scale 2, and let's leave the thickness 2 and test this out. Okay, so this is a little bit bigger now. You can increase it to get good results. So let's see. The first car is counted, detected well. This is also detected very well. Okay, so we have the third cars, and you can see the other car on the road, the one just detected now, is not being counted because we are just targeting a particular road. So this is working nicely. Let's see this one. That's 4. We are getting the track. That's 5. It's counting very well. This one is the other side of the road. Let's check. Boom, and it's working. So everything worked nicely, and this is just fine with this small line of code. So we have not even hit 100 lines of code to achieve this. So you can see this is fantastic. 7. Let's see, and the 8th car. So this is working nice. This is counting nicely. This is just part 1 of vehicle detection and counting. The next part we'll take road that has many cars and also a busy road, so that we can add other features to our code to suit that case too. So with this is simple because the road is just straight up and there are no other cars passing at the other side of the road, something like that. We are just taking one lane and working on it. So in other tutorials, we'll try ourselves with roads that cars are going to this direction, cars are coming to this direction, then we can just count on both roads or something like that. So I hope you've learned something new, and I hope you are going to try this. I'll put the code and every file associated with this particular tutorial in my GitHub repo so that you can have access to it and play with it and also improve it. Let me also have your thoughts in the comment section. And all I can say now is that thanks for tuning in, and I'll see you in the next tutorial.